Today we're going to be looking at slope fields and reconstructing graphs. Now on the left here we've got what we call a slope field. What it is a set of axes that has the slope of a line at any point. Alright, so we get this from the differential equation and we can plot this, or usually we're given this and we're asked to draw a line on the top of it. So when we're reconstructing slope fields, it looks like this. So we have the same slope field on the left and the right hand side. And what you do is you trace your line such that it matches the slope of the tangent at all points on your graph. So you can see down the bottom here, they're quite vertical. So it's going up, 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 up. And as these the slope field starts to bend, I guess is the word for it, and turn around, so does your graph. And it goes down again, turning point again, and then rises. Okay, so this is how what this one looks like. So if we've got a dy by dx, or the derivative equaling 2x, if we integrate that, it equals x squared plus c. Now, what we have here is if we've got, if we make our c equals 0, well, let's just have a look at our derivative function. It equals 2x at all times. So at 0, it's going to equal 2 times 0. So it's going to be a flat line. All right, so just a horizontal line. And that happens at every x equals 0 on this graph, including the negatives. Now, if we go across to x equals 1, we put 1 into our derivative, we get 2 times 1, which equals 2. So we get a slope of 2 at all points. And if we have negative 1, we get a slope of negative 2. And again, this happens for the positives and the negatives all the way down. All right, so this constructs basically the same. If we go to 2, it goes to 4, becomes a steeper graph. Oops, just imagine it's a bit steeper. If we go across to 3, it becomes 6, it becomes even steeper, and so on. So the way we've constructed this this slope field, we can go back and use the field to plot our point. So given this slope field, we know at the bottom it's flattening out and it's coming down this side. So it's going to look something like this. Now, it depends on our plus c value. So when we integrate a function, so we've integrated to get from here to here, when we integrate, we always put plus c. If that c is negative 2, it means this graph is going to be shifted down to go through the negative 2 there. All right, so that's just a quick look at slope fields. Let's have a look at another example now. All right, so the slope field for the differential equation dy by dx, so this is our differential equation, equals 2x, is shown below. So this is our slope field. What we want to do is sketch the solution corresponding to c equals negative 1, and also the one passing through 0 and 2. So first thing we want to do here is if we integrate this function, so dy by dx equals 2x, we can bring that x up, so dy equals 2x dx. We can integrate both sides. What we get is we integrate dy, we just get y. If we integrate x squared, we get, 2x, we get x squared plus c. Well, what we're doing, we're asked to sketch the solution corresponding to c minus 1. All right, so we're going to sketch the solution of y equals x squared minus 1. Now, that value there is going to go through the minus 1 and follow the slope line, so it looks like that. Okay, the other question, part B, is asking us to put the slope through 0 and 2 on the y. So if we go up to 2 on the y, up here, we can sketch that function like that. So this one is very graphical. Not a lot of algebra in it, a little bit if you have to integrate the function, but yeah, that's slope fields, and hopefully we can have got some of those now.